Alrighty, welcome back to 105. So, last lecture we covered strings, which brought together a whole bunch of things. Brought together arrays, brought together dynamic memory allocation, and all of that fun stuff. So, any questions from last lecture before we go into helpful things and functions that are provided to you in the standard C library that will help you in dealing with strings, although, as I will show you, some of them are tricky to get right. All right, we are good. Perfect. So, lots of string functions in the standard library. You just need to include, so hashtag include, angle brackets, string.h at the top of your code. That brings in a whole bunch of string functions that you are able to use. Throughout this, just remember C strings are just an array of characters that end with a null byte, and that signifies to tell you when to stop. Which sounds simple, but in practice it is notoriously difficult, because what happens if we're trying to print a string and we forget to put a null byte at the end of our string? We just keep on reading until we happen to hit a null byte, right? Which can, well, in more cases than not, is a bad idea. So, some of these functions are tricky to use correctly because, in general, to hold a string, you need enough memory to hold the string length plus one number of bytes. So each character is a byte, assuming we're just talking about ASCII, and then you need that extra byte at the end for the null terminated character. So, knowing that that plus one tends to be pesky, and remembering to put a null byte at the end also is a pesky thing. So, we previously wrote a function to give us the length of a string. So, instead of writing it ourselves, that is one of the functions that is provided to you. It just has a slightly worse name. So they tried to shorten it. Instead of being called string length, it is called str length, or strlen, sorry. So, str is short for string, len short for length. Don't ask me why they have to shorten it every single time. So, takes as an argument a C string, so it's a pointer to a const char because it's not going to try and reassign any of the characters in our string, and it returns this size underscore t, which for our purposes can just be an int. So, you can just explicitly cast the size t to an int, so we can just live in int land and we should be fine about it. And s has to be a null terminated string, so you might hear people say, or even I may have said it, a null terminated string or a C string, those two are one and the same. So in some languages, some people might be like, oh, the input's a C string, it just means it's a null terminated string. So, to get the length of a string using strlen, this is how I would do it. So, again, I include string.h. That brings me in a whole lot of functions I can use from the standard library, one of which is strlen. So, if I assign my variable on the stack called s, which is a pointer to a constant char, and I assign it a string literal, that means this is read-only memory, but it will be a null terminated string, so we can see that C does indeed make it set aside 12 bytes for it, so it can hold hello world and the null terminated character. So if I do strlen, that will tell me the number of characters in the string, not including the null terminated character. So if I run this, in this case, my string should be 11 characters long, right? Hello is 5 plus a space character, then world is another 5. So in total, should be 11. Strlen tells you 11. Don't have to write your own string length function. Just use strlen. So, maybe we're not sure the string is null terminated, so maybe that input comes from, I don't know, a user typing something or from the internet or something like that. So, it's generally a bad idea to use strlen if you don't know it's for sure null terminated, because it will just blindly read bytes until it does encounter a null byte, which probably isn't what you expect. So if you know the limit or how much memory you have set aside, you can use a function called strlen length. So strlen will this n, it just sticks an n after the str to indicate n is just like a limit. So it has a size you also have to specify. So this takes another argument, a size t, could just think of it as an integer called maxlen, and that will make sure that it is actually bounded somehow, that it will actually stop reading. It will only access the bytes if we use the array subscript s at byte 0 all the way up to maxlen -1, even if there's no null byte, even if we forgot to add one. This way we won't have any memory issues if we forgot to actually add a null byte and we know how much memory we are actually pointing to. So this means that the maximum value returned for by str n length is maxlen, even if the string itself is longer. So what I mean by that is if we look at this and we give it again the string hello world and we use str lang with the limit, so the n, and we try to determine the length of string s, and we say maxlen of 5, that means at most it will return 5 bytes as the absolute max length this function will return. So if I try to run this now, whoops, I can see that it returns me 5 even though the string itself is actually longer. If I wanted, if my max length was bigger, it would of course return 12. So if I increase that limit to 20, in this case, because I know it's null terminated, that will also be okay. It will return me 11 again as before. So this is a maximum just to make sure that if we don't know whether or not that string is null terminated or not, it is better to like truncate it and get a truncated result rather than some value, or rather than possibly accessing invalid memory. So next one. So here's that example. Again, that is the maximum length. So next one is str copy. So remember, you can't modify a string. So if I do something like char star s equals the string literal hello world, well, I can point to a string literal, but it is in read-only memory. So if I try to change the value or assign a character to one of those elements, I will get some error. Well, what you can do is you can copy a string to the heap with this str copy function. So it takes 2 arguments, one pointer that you malloc, you set aside, it's pointing to some valid memory. That's where to copy the contents of the string to, and this is the source. So what characters to copy from. So it will copy this character by character into dest until it reads, or until it also copies a new, or a null byte, and then it will stop. So this also returns a pointer, so it returns a char star pointer, but it's going to return the same address of dest. So again, C is the C string to copy values from. It doesn't try to modify it at all. And dest is the location to copy values into memory to. So it could be malloced. You could allocate it on the stack if you wanted to. Doesn't matter. So dest, the only rule here is that dest needs to point to at least str lang of the source plus 1 bytes of valid memory. So it has to be able to hold that the contents of a string plus the null character. And dest will be null terminated when we use this function. So example of that. So here it is again. So here we have our string literal. In this case, well, you might screw it up. And in this case, if we screw it up, in this case, in order to successfully copy this string, I need at least how many bytes or how many characters to copy this string into memory? 5? How many bytes do I need? Anyone? So it needs to hold the length of the string plus 1. $12. I heard a 12. So 12, right? So hello world, hello space world is 11, and then plus a null byte at the end of it. So If I accidentally do something like this, where I malloc size of char times 5, so I'm setting aside 5 characters on the heap, and malloc's returning me a pointer to the start of that, so I'm going to use it as an array of characters and call it D. If I use stir-n copy, where D is not large enough, so only the first 5 bytes are valid, well, we can see what happens. If we print out the value of S, it should be hello world, because that's pointing to that string literal. If I print out D, it's only guaranteed that I copy hello, which is the first 5 characters, because that's all I could fit. So if I run this, I tend to get lucky, and I see hello world in the other one, because again, it just blindly copies more information until it reaches the null byte of the source string. But if I use my good friend Valgrind and see how unhappy it is, whoops, and I run it, I can see that indeed, if I look it up and scroll up, it is very unhappy. Invalid write of size 1, so that was probably like the space character. Invalid write of size 1, probably the W character that was past the limit. Then the O, and then it skips a whole bunch of them because it happened a whole bunch of times. And then it gives me invalid reading, because printf will be reading that string and tells me that, hey, I malloced 5, I'm reading past that, and yell at me over and over again. Yep.
Wait, could you explain the str copy thing one last time?
So string copy, what we'll do I have an example of the code? So string copy will essentially just iterate over every single byte of the source string, so in this case S, and then copy all of its values to this array pointed to by D. So it'll copy like a capital H, then an E, then an L, L, O. So we'll just try and make this array a copy of the source. So it'll just copy all the values. So if you had 2 arrays, that'd be like making another array the same size and then assigning all the same values at all the same indices. Yeah, we'll need to change the size. Yep. Yeah, so that's a question here of if I actually call free on D, so I definitely leaked memory too. If I call free on D, will that free those 5 bytes or free all of the 12 I actually used? And the answer to that is it will only free the first 5 ones. But because I'm using invalid memory, I might actually screw up free and it might not work anymore. So it kind of depends. But yeah, that will only free the first 5 bytes. But as soon as you start writing to invalid memory, kind of all bets are off. So in order to do this properly, I would need to malloc at least 12 bytes because that is big enough to fit. So if I do that, compile my program and run it, whoops, run it without Valgrind first, I can see that now I get the correct answer. Looks the same as before, but if I run Valgrind again, I can see that now it is happy with me. It doesn't say invalid read of anything at all. The only thing it is angry at me for is because I definitely lost information because I forgot to free that. So if I want to make Valgrind happy, which is what you should strive to do, I would need to, I would need to free D at the very end. Let me format this correctly. So I would need to free D at the very end. Now, if I compile this and run this, I'll see that Valgrind is very happy with me and I get the correct output that I actually thought I should get. So questions about that? All right. So, whoops. So that was that example we just went over. D not being large enough, it looks like it works, but in fact we are writing invalid memory, which gets us in a whole world of hurt. So since we malloc space anyways and we know how many bytes we set aside, there is like with most of the string functions, one that you can set a limit. So this is str_n, so string with a limit. And there is a version of copy. Again, I don't know why they just didn't call it copy, why it has to be CPY. I don't know, don't ask me. We like to make things short. So has the same first two arguments as with string copy, place to actually copy the values to, and the second argument where to copy them from, and then size n, which is at most how many bytes to copy over. So this function, unlike the other one, always writes every single byte of all those 5 to dest. So in other words, what it will do is it will assign values from dest at index 0, if I use the array notation, all the way up to dest of n minus 1. So even if that string is smaller, it will assign all of those values for me. So it also has some rules that may get you into trouble. If n is less than that str length plus 1, so if the number I give it is not big enough to actually hold the entire C string, it will not null terminate it. It will just blindly copy characters up to that limit and stop. So it is not null terminated. It's guaranteed not to be null terminated in that case, which if you tried to print it, might get you into a world of hurt. So if n is greater than str length plus 1, so it can fit that or has more, then it will just be filled with all null bytes. So all of the values from str length, so the very last byte, all the way up to the last byte of that destination array will be filled with null bytes. So in general, since there's two cases here, if you use str_n copy, the string may not be null terminated. So you will probably have to check that yourself if you want to make sure you are safe. So here is an example of that. So it will save me a little bit. So this is a larger example. So this is my string literal again, hello world. I need at least 12 characters for it. If I print it out, I should see hello world. Now, I'll just create a variable called size that will actually malloc that number of things. So I'll set size equal to 6, and then malloc size of char times size. So I'm mallocing space for 6 characters. So I could use that pointer as an array. So it is going to be called D. Now if I use str copy D, so copy all the values to D from the string S and only go up to size 5. That means it will only copy, in this case, size is 6, so it will only copy from that array at index, let's scroll up, at index 0, 1, 2, 3, 4, 5. So it will copy hello and the space, and then that's it. So it will not be null terminated at all. So in this case, there's no overflow, so I'm not writing any invalid information past the end of what I allocated from malloc, but it doesn't have a null byte. So I can verify that myself. If I check the last byte, which is d size minus 1, I can indeed see that this will be true. So that character does not equal the null byte, which how you write it as a character is just single quote, \0, single quote. So this should print, so it should say that there is no null byte, and then in order to print it safely, I will just assign a null byte to the last character myself. So now if I print D here, I should see hello because it replaced that space by a null character. So if I printed it as a string, I should just see hello and nothing else at the end of it. Then, of course, being a good person, I would free my pointer. Then I can see that it indeed works the way I said. So maybe I set size equal to 16 now, do a new malloc, so malloc 16 bytes, and do string copy now with 16 bytes. So now I can actually get the length of the string that I copied from, which should be 11, so hello space world. And then I'll have this Boolean called padded zeros equal to true. So what it will do is start at index I equals str length. So start at the first character after the string and go until the last character in the D array. And then I will just check if D does not equal a null byte, I'll set padded bytes equal to 0, break, and then if padded zeros is not true, then, well, then there's not a padded 0 in it. If padded zeros is still true, that means indeed what I said was true, and the rest of the bytes are all null bytes. So this won't affect when I print D now. It should just be hello world, because that stops whenever it encounters the first null byte, which will be at the end of the string. And of course, I free my string at the end. So a lot going on there, but if I run this now, whoops, I have to look at the right screen. So now if I run this, I can see that when it was shorter, I tried copying hello, like I only set aside 6 bytes, so I initially just copied this with the space, looked at it, said, hey, the last character, which would be the space in that D array, looked at it, saw that, hey, indeed, there's no null byte, so I changed it from a space to a null byte so that when I print it, it successfully just says hello and essentially gives me the truncated result, which is probably what this function should do, because this is kind of annoying to remember. And then when I made the bigger one, it indeed says that the rest of the bytes are all null bytes and doesn't really affect what I print. It's just going to be hello world every time. So questions about that? Yeah?
I mean, if the length of the source string is exactly n, there still wouldn't be a null byte at the end, and you have to allocate memory for like destination at index n.
Yeah, so the question is, what if the string is like, what about if the size I set aside is exactly the length of the string, right? So if it's exactly the length of the string, then it will copy all of it, not including the null byte to that one, and that the string you have will just, in this case, end with a D, so it will not be null terminated. So it should, if I run it, just say, hey, there's no null byte at the end, and in order to safely print it, I changed the last character to a null byte so it safely prints it. So I essentially lose the D there. So if I didn't do that, it doesn't end in a new byte. That last character would just be a D. So in order to safely do it, I have to make sure it will actually fit. Yeah, and it's also a way to check that, hey, oh, if it doesn't end in, if the last character of my array is not a null byte, it was not big enough, and it definitely got truncated somehow. So you can use that to your advantage if you want. All right, so other fun ones. So we can extend one string with the content of another. In other words, we can concatenate or add 2 strings together. So there is this function. Again, don't ask me why we shorten it. Stir cat, so cat is not like a meow meow cat. It is short for concatenate, a lot less exciting. I don't know why it wasn't concat, don't ask me why. So how it works is it copies this source string to the end of destination. So it will start copying source from the null byte of destination and essentially add that source string onto the end of destination. And this gets really tricky for handling memory because dest must be able to hold the length of the string that you're adding to it plus the length of itself plus 1 byte for that null terminated character in order to be safe. So that is typically a lot to keep track of, or more complicated than you might expect, and is likely a source for errors that you probably want to check for. So how to use that one? So we could create a string or create a variable called s, which is a pointer to a string literal that is just space world, and then we can set aside 12 bytes. So we can malloc size of char times size. So this is pointing to enough room to hold 12 characters, which we can use as an array. And then we can use stir n copy. So we can initialize the beginning of string D with the string hello and up to size, which in this case it would fit. So it would be hello followed by a null character, which is 6. And then we can add on to it. So strcat, dest is what we're adding on to, and source is what we're copying from, or what we're copying from. So in this case, it will just start adding it to the end. So it will replace the null byte by space world, and then add a new byte or a null byte on the end of that. So thankfully, in this case, it fits. So if I put s, which again is just a shorter way of just printing a string with a new line, I should actually see the string what? I should actually see the string hello world in this case. So now I see the string hello world, all is good. It adds it to the end. Other languages make this a lot easier because you don't have to argue about what the size is of anything. You just let the language do that for you. But unfortunately, we are in C land where you have to manage your own memory. That's just how it is. So questions about this? Yeah?
So you copy the hello to D.
Yep.
And that's just world, so you just print it out.
Yeah.
And then you added you concatenated the two strings.
Yeah, so to D, after I do string copy, it's like saying like part of the string copy would like do D at 0 equals H, D at 1 equals E, so on and so forth, all the way up to, what is it, 5, and 5 is going to be the null byte, right? So what strcat will do is take D and add this string on to the end of it. So what S is pointing to, whoops, make sure it fits in the screen. What S is pointing to is space world. So it will just assign, starting at the null byte, it will replace that by space, and then just keep on adding to it. So it will do W all the way until it's done world, and then finally at the end, it would set byte 11.
By itself?
Yeah, it will add a null byte.
Okay.
Yeah, so it will move that null byte for you and add it to the end of it. So this one guaranteed to be terminated with a null byte, that D string after I concatenate it, but again, not guaranteed that it falls within the limits. Again, if I did something, I don't know, like this, set the size equal to 5, then it's not big enough. If I compile and run it, probably looks like it works, but technically we're not guaranteed this will actually work, and our program might crash when you run it on the testing machine. I have seen a lot of students running, or at least on Piazza, posting out of memory errors. That is because you are likely mallocking or dynamically allocating an array with an uninitialized variable, which tends to be a huge number, and then I think the testing machines let you use up to like 100 megabytes of memory without crashing, but because it's a super large number, you allocate a huge swath of memory, you go out of memory and your program crashes, and it just so happens on your machine that's probably initialized to 0, so it works for you, doesn't work in general. Again, you should use Valgrind all the time for your programs, but just because Valgrind says there's no issue, doesn't mean there isn't an issue. If it says there is an issue, there is definitely an issue. So you should at least run it though. It gives you at least a little bit of peace of mind. All right, so just in case you're curious, if we were to implement strcat ourselves, this is how we could implement it. So I think this was on an exam at some point. But if we were to implement it ourselves, so dest is pointing to a string, and we're just trying to tack on this source string to the end of it. So we can find the current length of dest by using strlang. So if we access the byte at dest len, that should be a null byte if dest is pointing to a null terminated string. Then we can create a variable called size t. Just think of it as an integer I, and then we can loop over all of the values from that source string. So looping over all of the values from the source string, I would start copying it at the end of dest len plus I. So this would copy or overwrite that null byte, and also copy that copy every single character not including the null byte. And then at the end, whatever I is equal to, we can just make sure there is a null byte at the end of the string, is how we could implement strcat. So strcat would just look something exactly like this. Note doesn't have any limits on size or anything like that. It will just blindly copy values from from the source string until there is a null character. Doesn't have any other complicated logic or anything like that. So, as you may have guessed, there is another function that has a str_n that has a limit. So we can limit the number of characters we're copying. So similar to copying a string, you can set limits with str_ncat. So dest, source, and then n, and then that will copy at most n bytes from str. And in this case, that source string does not need to be null terminated. So it will end early if it's null terminated. If it will not, if it is not, it will stop after n bytes. So this n is related to how many bytes we read from source. So that function always adds, this one is safe, it always adds a null byte to the end of dest. So dest must point to at least, in order to copy the entire string, strlang of dest plus n, so how many bytes we're going to copy from the source string, plus 1 bytes of valid memory, and you have to ensure that. So if we look at a more complicated example, so this time I'll just allocate a variable called s, which is an array on my stack, and just set equal to space John. This is what the string literal thing will do anyways, but just to show you that indeed it is an array of characters, this is just space John with a capital J, and then here I have my array length macro. So since I'm using, or since I have this array length macro, and s is declared on the stack, so it's declared in this function, and I let C pick the size of it, it is a real array. So if I try and use s, it will array decay. If I try and use it in other contexts, except for array length. So this type is actually an array. So if I set the size equal to 10 and I malloc space for 10 bytes, and then I copy hello to that string and say copy at most size bytes, so in this case it fits. So at this point D should point to the string hello that is null terminated, and then here strcat doesn't take into account the number of bytes in D. So this will copy just however many characters, or copy at most the length of the array from S into D, and that's it. It won't do anything smarter than that. So if I go ahead and run this, or ncat, I can see indeed it works. It says hello John, no harm, no foul. But if I do something like this, let's say I make the size much smaller. So let's say I make the size 7. If I try to compile and run this now, I still get hello John, but I'm overwriting memory, right? So that only the first 7 bytes are valid. If I try and run it using Valgrind, I will likely see that it is very unhappy with me. Again, that invalid read of size 1, invalid read, invalid write, because I'm going over that limit. So even though it has a limit, that limit only applies to that source string, which in general doesn't really help you, because this D array is the thing that actually has a scary limit that you want to make sure you do not go over. So the other code is better. So if I do something like this, where again I use D and S, well, I can actually know what my limit is going to be. So at most, the number of bytes I can safely copy from S is, well, the length, the total number of bytes I have allocated minus the size of the string as it currently stands, which in this case is 5 bytes because it is hello. So again, that doesn't signify the null character. And then minus 1 because I have to store the null character at the end to actually terminate the string. So this will actually only copy characters from str up to something that is actually safe to store in D. So now if I run this and I run it, I'll see that it is safe because, well, I don't actually see anything different, but what is actually here is it copied just a space. So HELLO and then a space, that's 6 plus a new byte, so that's 7. So if I change that to 8, I should see hello J. So compile it, run it. Now I see hello J. It's nice and safe. It will truncate it. But again, if we run this, Valgrind will not yell at us. We will not have undefined behavior. And you can probably debug this if you see something has shrunk. Yeah?
We're getting memory from the heap, and then we're looking at the line for the leftover bytes after copying hello into deep.
Sorry?
So that we get memory from the heap, right?
Yeah, so we're allocating size characters from the heap.
Yeah.
Size of a character is 1.
When you copy hello to D, it takes some space, so we have to find the leftover space by doing size minus str length.
Yeah, so when I stir copy to it, I'm setting the first, in this case, 6 bytes, so hello, and the null character. So this is setting that. And I had a limit here. It was below the limit, so it was all good. And then strcat will just add this string to the end of D. So D is currently hello with a null byte, so it will copy information from this S to des starting at the null byte. So we'll just tack it on to the end, and what it will tack on is space JON, and then it will also add a null byte at the end of it.
It stops at J.
Yeah, so in this case, if I set the limit to 8 here, so at most, what I can safely store, if I malloc 8 bytes, at most I can hold 7 characters in my string, right? 7 characters in the null byte. So yeah, so that's why I set my limit here. So what I can copy from string is, well, hello's already there. So of those 8 bytes, 5 are being used for hello, right? So 5 are being used for hello, so I have 3 left. I need to set 1 aside for the null byte, so that means I have 2 left. So in this case, I can only safely copy 2 characters from this source string. So that's why it only copies, in this case, space J, because that's the most I can safely copy to it. Everyone good? All right, strings are fun, right? This will, yeah. Part of learning C is you will screw this up. It will be very hard to debug. That is why I'm trying to show you all the ways you can misuse it. All right, other thing. So you can compare strings with each other. So you can use the function strcomp, so short for string compare. And this only reads the strings and it compares one string to another. You might see it does not return a Boolean or anything like that. It returns an integer. That integer signifies a few things. The only thing that's defined is if that integer is negative, so any negative value, undefined what that value should be. If it's negative, it means that string 1, so what is on the left, is less than what is on the right. If it returns a value of exactly 0, it means the contents of the string are exactly equivalent. If it returns a positive value, that means string 1 is greater than string 2. So, if you want to compare the content of strings, you need to use this function to compare strings. Otherwise, you are comparing addresses. So if I just compare S1 and S2 without using string compare, that is comparing 2 pointers to each other, which is just going to compare their addresses. So that will only return true if their addresses are the same, and false if their addresses are different. So if their addresses are the same, that means they're pointing to the same string, which technically means they're pointing to the same values as well. But because 2 addresses are different, doesn't mean the strings they're pointing to are different at all. So what strcomp does is it compares both strings character by character. It dumbly just uses the ASCII value. So have any of you in macOS or Windows ever went organize alphabetically and it did something stupid, like it put 10 before 9? where you're like, hey, 10 should come after 9. What the hell are you doing? Well, that's because it treats your files as a bunch of characters. So it just goes character by character comparing their ASCII values. So if I compare the string 9 to the string 10, you might think that 10 is bigger than 9. But string-wise, what it will do is it will compare the character 9 to the character 1. And in that case, the character 9 is greater than the character 1, so it will return a positive value, which means the string 9 is greater than the string 10. So this is why, again, if you organize by name in Windows or something like that, it does not behave properly with numbers because it just compares character by character. And it will also take the null byte to account. So if I compare the string JO to the string JON, well, it will compare the first character in both strings. They're the same, so it needs to move to the next character. O and O are the same, so we're going to move on to the next character. Then it will compare the null byte to an N, which means that a null byte is less than, which is just 0, is less than the character N, so that will return a negative value, which means JO is less than John. And similarly for this, the length doesn't matter. So if you do AAA compared to B, well, it will just compare the first character A to the first character B. If there's a difference between them, it will immediately stop there and not continue. So in this case, A is less than B, so it will return negative. The string AAA is less than the string B. So if I were to use it, so if I were to use it and I have the string alpha and I have the string beta, well, this is typically how you would use it generally. So you would say if str1 compared to str2, if it is less than 0, that means that S1 is less than S2. Else if it returns a positive number, so it is greater than 0, that means S1 is greater than S2. Else, I know that it returned a 0. It returned exactly a 0. So I know that S1 and S2 are the same. So if I compile this and I run this, str and comp, I'll see that S1 is less than S2 because, well, it will just look at the first character. The character A is less than the character B, so it will say S1 is less than S2. So everyone okay with that? Just how it works. All right, so fun other one. This is where you may get into trouble. You will probably encounter this at least once. So let's say I have the string testing. I figure out how many characters are in it, and then I malloc space for S1 and S2. So what I can do is I can concat to the end of it or copy, it doesn't really matter. Copy to S1 the string testing and limit up to strlen +1, so it can fit that plus the new line, plus the null byte. And then same thing here with S2. So I copy that. Initially, it has nothing, so I'm all good. So here, their strings are the same. They should be testing, right? So you might think to write S1 equal S2. And then in that case, it should be the same because they're both that string testing. Otherwise, it should print out the pointers are different. Then here, I can see what happens if I use strcomp. So there is a version of strcomp that has a limit. So there's strncomp that will stop after n bytes. So I could use strncomp S1, S2, go up to slang +1, see that if it returns 0, it means the contents of the string are exactly the same. Otherwise, the contents of the string are different. Then I can free both of them, and then, oh, this was just testing to see, comparing AAA to B. So we can comment that out. So if we go ahead and, compile that code and run compare, we'll see when we do it that the pointers are different because, well, they're two different malloc spaces, right? They live in a different space in the heap, And when I do S1 equal S2, those are comparing the addresses of the pointers. So malloc always returns a unique address. So in this case, they will not be equal to each other. So that's why this prints off the strings are different. But generally, when you compare strings, you only care that the contents of the strings are the same. So always remember to use stir comp. So now if I do this, I can see that, yes, indeed, the contents of the string are the same. In this case, they both contain the string testing. So, word of warning. Everyone got my word of warning? Use stir comp. Otherwise, if you compare just two pointers, you're comparing the addresses of the pointers, which is most certainly not what you want to do. So again, here's comparing within limits, stir n comp. In this case, the strings do not have to be null terminated, and it stops reading early if there is a null byte in another string. Otherwise, it will go up to that limit. So in this case, if I run it with stir comp, and I set a limit of string 3, and I compare the string John Elfson and John Stewart, in this case, it will only compare the first 3 bytes. In this case, the first, or 3 characters. In this case, the first 3 characters of these strings are the same. So it will actually print off that S1 and S2 are the same, because I'm only looking at the first 3 characters, which in this case, they're both equal to John. So other functions, I can search for a string within a larger string. So this function will search for a substring. So it's called stir, dumb name. So this will search for in this string called a haystack and search for this called needle. And it will return a pointer to the starting character of needle in haystack, or null if it doesn't exist. So if the returned not null pointer, it will point to the character in haystack. So what that means is if this is my string, this is a long line, and I'm searching for the string long, if f, which is returned from stir string, does not equal null, then it will point to the starting location of long in the larger string. So it will point to this character here. So if I print it, it will print out long line with an exclamation mark. So it returns a string into this S string. So it's a way to find a string within a string. And we'll see more examples in the next lecture because time will be tight. So you can also find a character in a string using stir char. So you can say what string to search and then what character to search for. Again, this will return a pointer to the character in S, or null if it is not found. So if I search for the character W, it will return me a pointer to this first W here, which would be world. So which would be this W in world. So if I print it out as a string, it will just go until the null byte, so it will just simply print world. So there's other functions you can use to convert a string to an int or a double. There's a to I, so a string to an int, and then a to f, so a string to a double. So it will return that, convert it to value for you. So here's an example of using that. It will just make value equal to 1, 2, 3, 4. And same with double, 1.337. It will just go ahead and assign that to you as well from a string. So here's a summary. We went through the first 2, whirlwind. So the last 2 are in standard lib.h to convert a string to an int or a double. This is for you to help you with the labs. Lab 7 will probably involve strings. So these are all the functions you can use on a handy dandy slide for you to refer to. So with that, that is time. So just remember,